Hello students, welcome to the lecture series on the subject Data Structures and Algorithms. In our today's lecture, we will study stack data structure, the operations and applications of stack data structure. What is stack? Stack is a linear data structure, and as we discussed in our previous lecture, the definition of the data structure is data structure is a way to organize and store data in a computer. So we will see how stack organizes data and what are the different operations which we can perform on a stack. So let us see how stack organizes and store data. For this we will see one example. The coins are arranged as layers on one another. So you can see in the image, the layers are increasing and the recently added coin comes on the top of the layer. And we cannot take out any of the coin from the layer in between. Otherwise, the arrangement will collapse. So this is the example of a stack. So the formal definition of a stack is an ordered list in which all insertions and deletions are made at one end called the top. Stack is a linear data structure which works on last in first out, that is LIFO principle. Means the element which is inserted at last in the stack will come out first from the stack. So this is the definition of a stack data structure. So now we will see the working of stack data structure with one example. So the figure shows an empty stack and top is a pointer which is initialized to -1. When we will insert the first element into the stack will look like this. So we have inserted element 10 into the stack and now the top is incremented by 1 and it is pointing to the first element which is recently inserted into the stack. Now if we insert the second element into the stack, top will be incremented by 1 and top will point to the element which is recently inserted into the stack. If we add third element, then top will become 2 and top will point to the element which is inserted into the stack. This insertion of elements into the stack called as push operation. Using push operation, we can insert element into the stack, and whenever we insert one element into the stack, the top pointer is incremented by 1 and the pointer points to the element which is recently inserted into the stack. Let us consider the stack again. In this stack, now the element which is on top is 30. So if we want to remove or delete the elements from this stack, the deletion operation will look like this. So whenever the element will be deleted, top will be decremented by 1 and top will point to the next element which is on the top of the stack. So now as 30 is deleted, the top pointer is pointing the element 20 and the top pointer value is also decremented by 1. When we delete 20, the top will point to the element 10 and the value of top is also decremented by 1. So it is 0 now. There is only one element into the stack, and when we delete this element also, stack will become empty, top will become -1 and this deletion of elements from stack is called as pop operation. So I hope it is clear that how push and pop operation works. Now we will see all the operations which we can perform on the stack in detail. Stack operations are, the first operation is create stack. So this create function will return an empty stack. The second operation, push I, S. This operation will be used to insert the element I onto the stack, which we have already seen in the previous example. The third operation which we can perform on the stack is pop, which removes the top element of the stack S. So the third function is pop function, using which we can delete the elements from the stack or remove the elements from the stack. The fourth operation is we can check which element is currently on top of the stack. So top function will return the element which is on the top of the stack S. The fifth function, that is empty stack. Using this function, we can check whether the stack is empty or not. If stack is empty, it will return true, else the function will return false. That is, it will return Boolean value 1 or 0. There is one more function which is used as a stack operation, but that function is only used when we implement stack using array. And the function is full stack. This function will return true if the stack is full, else false. Now, as I said, we will only use this function when we implement stack as an array, because when we declare stack as an array, we define some size to that array, and once this size limit reaches, we cannot add new element into the stack. So when we will be implementing stack as an array, this function we will use. But if you implement stack as a linked list, we don't need its full function, because in linked list we can add as many nodes we want. So its full function will be only applied when the stack data structure is implemented using array. So these are the stack operations which we can perform on stack data structure. Stack as an ADT. So let us see how to write an ADT of a stack data structure. The structure stack, first function will be declare create function, which will return an empty stack. The second function push, which will require two parameters, item, and we will pass the stack. And this push function will push the item onto the stack and it will return a new stack. Then using pop function, we can remove the element which is on the top of the stack. For the pop function, we will pass the input parameter as a stack and the return parameter or the function will return stack as output. The next function is top of the stack. Using this function, we can check which is the element on the top of the stack, and that element will be returned by this function. And the last function is empty. Using this, we can check whether the stack is empty or not. This function will return value 1 if it is true, that is stack is empty, and it will return 0 if stack is not empty. For applying this function, what are the general rules which we should follow are stated below. That is, if we call the create function inside its empty function, then it will return the answer as true because the newly created stack is always empty. If we call push function inside is empty, then the is empty function will return the answer or value as false because the push function will be executed first and it will insert the element into the stack and stack will no more empty. If we call the create function inside pop function, it will give an error because as the create function creates the empty stack, there is no element on the stack, so we cannot perform the pop operation. So if we call in this order, the function will give error. The next function, if we call the push function inside pop function, then the recently inserted element will get deleted from the stack. And if we call create function inside the top function, again the function will give error because as the stack is empty, there will be no element on top of the stack. And if we call the push function inside top function, then it will return the recently added element. So these are the rules which tells us that which function we can call inside other, whether it will execute or it will give an error. So this is about stack ADT. And to implement stack data structure using any programming language, we first need to write this ADT and we need to define all the rules, then only we can implement the data structure. What are the applications of the stack? Stack can be used for conversion from one form of expression to another. That is, using stack we can convert infix expression into postfix, postfix to prefix, and so on. The second, for evaluation of an expression, so you can take an infix expression and using stack you can evaluate that expression to find out its value. The third application, to check for balanced parenthesis in an expression. So using stack we can check whether the number of opening and closing brackets in an expression are equal or not. Then stack is also used to handle the recursive calls where the stack holds the sequence of execution of the call. And in backtracking problem also stack can be used. And the last application is for memory management. So these all are the applications where we can use stack. In the next lecture, we will see in detail the first application of stack, that is how to convert one form of expression into another in detail. Thank you for watching.